Okay, you guys look good there. Let me share my screen. Let's see. This should still be active. Yeah, that's fine. Don't worry about it. Okay, so we're working on section 1.5. Okay. So we'll start here. Come on. Yeah, for some reason it keeps like defaulting back all the way to the top of the list. It's like I keep scrolling down and it keeps scrolling up. Right there. Finally. Okay, so no major announcements. Let me see. On Monday, we were working on section 1.5, on library functions. We got through most of the lectures, so today what we're going to be doing is working as many homework questions together from that section as we can. Okay. As usual, if you have questions, comments, or concerns, feel free to either unmute yourself or type in the chat. Yeah. Okay. Hey, Google, give me a random number between 1 and 20.
19.
So this question says, let F be the function that associates the employee number X of each employee to a corporation with his or her annual salary F of X in dollars. Suppose each employee was awarded a $200 across the board raise and an additional 5% of his or her increased salary. Write a function P of X to describe the new salary. Okay. So let me get rid of this, settings. So if their salary is F of X, right, and first they were given across the board raise in their salary of $200, so we're going to say the F of X plus $200, right? But then it says that there's an additional 5% increase. There's a 5%, an additional 5% of their increased salary. So what we're going to do, we want to increase this result by 5%, right? So in order to increase it by 5%, we need to, like 100% would be this salary plus 5%. So the new salary needs to be 105% of this, right? So we're going to say times 1.05, okay? Okay. So we can distribute and simplify those numbers. We're going to get 1.05 times F of X plus, now let me see, 10% will be what, 20? So then 5% would be 10. I feel like it's $210. I think that's it. Okay. Hey, Google, give me a random number between 1 and 20.
20.
Okay, so it says in the given graph, the temperature in degrees Fahrenheit of a home is given as a function of time in T hours after midnight over a 24-hour period. At what temperature is the thermostat set during the daytime, and then what temperature is it set overnight? So what's the daytime temperature here? It looked like it's what, a quarter, and you feel free to type it in the chat. I am monitoring the chat. You can see it on the screen. See if I can clear this. Okay. Oops. So during the daytime, a quarter of the way between 72 and 76. So halfway between 72 and 76, like it's what, 4? So 74. So then halfway between that would be what, 73. So let's go 73 degrees Fahrenheit. And then overnight is 3/4 of a way between 48 and 52. So halfway between 48 and 52 would be what, 50? So it's halfway between 50 and 51. Sorry, 50 and 52. So it looks like that temperature is 51. Okay. The homeowner reprograms the thermostat to T of T minus 4. Explain how this change affects the temperature of the house, and then graph the new function. All right, so this section is all about transformation, transformation of functions. So notice that we subtracted a 4 on the outside of our original function, right? So outside manipulations typically cause a vertical change and they follow our intuition. So then this should be T of T that went down by 4. Okay. So that should lower the temperature by 4 degrees. So the one that went down by 4. So the temperature change needs to occur about at 11 o'clock. So 6 does look like it's correct. 6, I mean B. And then we dropped it down by 4, so that needs to be 47. Wait a minute. If that is 74, so then it needs to go up to 70. So B doesn't look right. Let's try A, and 70A looks better. So then the homeowner reprograms the thermostat to T of the quantity T plus 5. Explain how this affects the temperature. So we're adding 5. So if we think in terms of transformations, right, we're saying plus 5 on the inside of our function. So if we add 5 on the inside, that means we're going to move horizontally, and it's the reverse of our intuition. So because positive X is to the right, intuitively, we might be tempted to say, oh, this goes to the right by 5 and the positive X, but it's actually the reverse. This one should go to the left by 5, making the temperature change occur 5 hours earlier. So let's go with the second one. Okay, so then which of these graphs captures the 5 hours earlier? Originally, the temperature change occurred around 11 a.m. So then around 6 a.m. will be the new temperature change. And it looks like D. Okay. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 9.
I feel like she keeps saying the same options over and over. I know she did some of the good amount of those with my last group. Okay, use transformations of f of x equals x squared to graph this function. 1, 2, 3. It looks like there's a total of 4 different transformations. So the recommendation is whenever we do multiple transformations in one equation like this, the recommendation is to work our way from the inside to the out. All right. Start with the innermost nested manipulation, which is going to be the -6 in this case. So the -6 is on the inside of our basic function. That means this should cause a horizontal change and it should move to the right by 6. So let me click on the graph. And since we're working with the parabola, because the base equation is x squared, I'm going to choose my parabola tool. Come on. Okay. You're not going to work if I do that. I think I might need to zoom. Change my light. Can I just clear? There it is. Okay, so if we click on the parabola tool, right? Normally, so we're gonna just track the vertex, right? So I put 1 point, and then I put the point 1, 1. I'm gonna track the vertex. So the first transformation, we have that -6 on the inside, so that tells us to go to the right by 6, right? So I think this one goes to 7. This one goes to 6. So then working our way from the inside to the out, we multiply the outside by a number larger than 1. So that's going to cause a vertical stretch by a factor of 2. So I think this just goes up 1 space like that. So we went right 6, stretch vertically by a factor of 2. Next, we multiplied the outside by a negative, so it should flip. This needs to go to where 7, -2. No. -2, -2. Okay, I think that's okay. Oh, and then lastly, we need to go up 3. So this goes up to 3. And this one goes up by 3. 1, 2, 3. I think that's it. Okay, was that it? Oh, I think we need to check it. Let's check this. Okay. Hey, Google, give me a random number between 1 and 20.
Here's a random number. 12.
Let me zoom in some. So write the function whose graph is the graph of y equals the absolute value of x, but it's shifted to the left 3 units. So in the chat, how do we capture that shifting to the left by 3 units, where the base function is absolute value of x? All right. So we said something about when we move side to side, or whenever we have a horizontal change, we said whether that's an inside manipulation or an outside manipulation. All right. Okay. Let me do this one. So write the function whose graph is given but shifted to the left by 3 units. So left means we're doing a plus x or plus 3 on the inside. So it should be the absolute value of x plus 3. Hey, Google, give me a random number between 1 and 20.
Here's a random number. 3.
You have to forgive me. I totally want to take a nap. Like I'm I'm trying not to stare at the clock. But yeah, I usually take like hella naps before I meet with you all, and I just did not do that today, and so I am paying the price. Describe how the graph of the following function can be obtained from one of the basic graphs, right? Okay. So this basic graph is called what? The reciprocal function, the 1 over x. It's called the reciprocal function. And all we did, we took the reciprocal function and we multiplied it by 9, right? Okay, so let's see. Start with a graph of 1 over x. So that's a reciprocal function. We want to stretch it vertically by multiplying each y value by 9. All right, whenever we do manipulations outside our basic function, that's going to affect our y values. When we're doing manipulations inside our basic function, that's affecting our x value. Okay. Hey, Google, give me a random number between 1 and 20.
6.
This one. Okay, so use transformations of the absolute value of x to graph the following function. We have absolute value of the quantity x plus 3, right? So notice we're adding a 3 on the inside. Let me open up this poll. This one, launch. Okay. So then if we're adding 3 on the inside, right? You should have it by now. Is the result going to be option A, B, C, or D? Where in A, it looks like we went to the right by 3. In B, it looks like we went down by 3. In C, we went to the left by 3. And D, we went up by 3, right? So if we add 3 on the inside, is it A move to the right, B moves down, C moves left, or D moves up? Okay. Okay, so I got at least one vote for C. Let me see. Plus 3. Plus 3 on the inside should be a horizontal. Okay, C is promising. And it should be the reverse of our intuition, so it should go left by 3. Okay, I can get down with that. Let's see. Check. Cool. Okay. Hey, Google, give me a random number between 1 and 20.
12.
12. Okay, since we did 12, let's go to 13. Okay, let me reset this poll. Let's launch. Okay. So this one says, write an equation for the function that has the graph of the given characteristics. It's the base function is a parabola, but it's up 3 units. So which of these options capture that between A, B, and C, and D? Let's read through this one more time. So it has the shape of y equals x squared, so it's a U-shaped curve. If it's upside down, all right, that means we're multiplying the front by a negative or the outside by a negative. Shifted to the right 2 units. So right is the positive x, so we need to say minus x on the inside. Okay, if we had to have minus x on the, or minus 2 on the inside, it has to be either A or B. All right, and then it says right 2 units and up 3. Okay, so the only one that went right 2 and up 3, I'm thinking it's yeah, I think it's A. I think it's A. Okay. Okay. Hey Google, give me a random number between 1 and 20.
9.
Okay, so let's do 10. Let me reset the poll. Relaunch. Okay. I'll give you a moment to try to submit a result here. So for this one, it says begin by graphing the absolute value function, right? And this gives you a chance to get some feedback, right? Some live feedback. And it's, I mean, the way I'm doing it is anonymous, so nobody's gonna know, you know. There is a vote for B. Let's keep going. The parent function is absolute value of x, then use transformations to graph this function, right? I see a total of 3 different transformations, all right? The first one being the -1 inside our function, right? There's a -1 inside our function. That should do what? Move it to the, hopefully you're thinking to the right, because that is correct, right? Absolute value, the vertex moves right by 1 and then down by 2, and it should be upside down. So right 1 down 2, or actually the order is right 1 upside down, and then down by 2, right? Okay. Right 1 upside down and then down by 2. Okay, I think there's a vote for B. Right 1 upside down. Oh, they got us. It looks like B, and that's not your fault because it is, I didn't blow it up. But B looks like it went right 2 and down 1, whereas C looks like it went right 1 and down 2. So I'm going to go with A. I don't know what I'm saying. Like, I'm totally sleepy. Like, I meant to say A. Okay. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 15.
Okay, let's see what we got here. 15, okay. So use the graph y equals f of x to graph the function g of x, which is f of x minus 1. All right, let me reset the poll. Launch. Nope. Yeah, launch. Okay. So notice the -1 is outside our basic function. So you got to think, is it vertical or is it horizontal? And then how does adding a positive number, how does that affect it, right? So do you think the option is A? I don't know if you can see it or not, right? So if we say -1 on the outside, it should move the whole graph down by 1. The only one, let me see, A looks like it went up by 1, B looks like it went down by 1, C went to the left by 1, and D went to the right. So we said down by 1. So I think it's B. Let's go with B. Okay. Okay. Hey, Google, give me a random number from 1 to 20.
10.
10. I see 10. So then 11 is the next one that's available. Okay. We need to talk about this one. Let me walk you through this symbol. All right. So this symbol in this question is called a step function because its graph looks like the steps on a staircase. So the greatest integer looks like this. And so basically what we're going to do is the result of this is going to be, actually, let me work an example or two, right? So the greatest integer less than or equal to, let's just start off with 2.5. So the greatest integer less than or equal to that is going to be 2, right? If we think about the number line, if we said 2.5, 2 is here, 2 is here, 3 is here. So then 2.5 is about here, right? So whenever we do the greatest integer, we always take the integer to the left. Okay. Suppose we did the greatest integer less than or equal to, say we did 2.1. Okay. 2.1 is going to be about here. The integer to the left is 2. So that one is going to be 2. What's the greatest integer less than or equal to 2 itself? Anybody have a guess at this result? Greatest integer less than or equal to 2. So when it comes to this greatest integer function, whenever we get an integer on the inside, we just take that integer, right? So because 2 is an integer, we just take 2, okay? So notice how all these points were between 2 and 3, we took the integer to the left. So, suppose I had like a negative 1 point, I don't know, 1, 2. Okay, so negative 1.12, sorry. Negative 1.12 is between what? Negative 2 and negative 3. So say this was negative 2. Sorry. This is negative 2 and the other one is negative 1. Okay. So negative 1.12 is about here. So then what's the greatest integer less than or equal to a negative 1.12? In other words, what's the integer to the left? The integer to the left, in this case, is going to be negative 2. Okay. So whenever we're working with the greatest integer function, you got to think about the number in question is between which two integers. And then if it's between two integers, you just take the integer to the left. If it's an actual integer itself, then you just take that integer as is. You don't move it. Okay. And so then if we were to plot the points, basically whenever we get like a result that's between two integers, all of those results collapse to a flat surface. And then it picks back up, it jumps up one step when we get to the next integer. So then when you put it all together, the graph ends up looking like stairs on a staircase. It says to graph the function started with the function from the library of functions and then using techniques of shifting, compressing, stretching, and reflecting to generate this. Okay. So the greatest integer function, again, it looks like the steps on a staircase. So now if we think in terms of transformations, where we start with the innermost nested transformation, which is that +2 on the inside, adding 2 on the inside should move it where? To the left by 2. Okay. So normally the origin is filled in. Then we multiply the outside by 3, which is larger than 1. So that's going to cause a vertical stretch by a factor of 3. And we say move left by 2. And it is C. Let's go with C. Check. Mic check, mic check. 1, 2, 1, 2. Check. Come on. Okay. I feel like there should be questions there, but I'm just going to let it be. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 15.
15, okay. Let me see. 15, so let's go to 16. Use the graph of y equals f of x shown below to graph the function g of x equals f of 1/2 x. Okay, let me see. So the graph of f of x is given, and we multiply the inside by a number between 0 and 1. So inside manipulations cause horizontal changes, and they're the reverse of our intuition. So intuitively, I know if I multiply by a number between a smaller number that's between 0 and 1, because it's on the inside, I know it's the reverse. So instead of causing a horizontal shrink by a factor of 1/2, this one should cause a horizontal stretch by a factor of 2. Okay. I use the graph of y equals f of x shown below. So that's going to cause a horizontal stretch by a factor of 2. The only one that looks like it's been stretched horizontally is B. So let's go with B. Okay. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 5.
I think we did 5 already. Okay, let's do 5. Given the graph the following function. So this one is a square root function where we added 4 on the outside. So that should cause it to go up by 4, which should be A. Okay. Hey, Google, give me a random number from 1 to 20.
Here's a random number. 4.
Did it already open or something? More. Sorry. There we go. So graph this function. We have y equals x squared minus 3. So it looks like it's going to be a U-shaped curve shifted down by 3. So I'm going to click to enlarge today. There it is. U-shaped curve shifted down by 3. So I'm clicking on my parabola tool. I'm just clicking anywhere on the graph. So it's this graph, but we want to go not stretch, shift, a vertical shift of -3. Okay, let's hit save. Check. Okay. Hey, Google, give me a random number between 1 and 20.
18.
Okay. We just about got through all of them. Let me see. A graph of y equals f of x is given. No formula. Make the graph. Okay, make a graph of this function. So let me restart this poll. All right. So what do you think is the result here, right? Let's take a minute or two just to think about it, and let's try to submit a result. Non-disclosure agreement. Let's see. See if I can. Hey Siri, play the Jeopardy theme song.
Here's Jeopardy main theme by Deep Music.
So just take a moment and see, can you get this one? Is it A, B, C, or D? All right. So let's talk about this. So now looking at it, I'm seeing 1, 2, 3, 4 different transformations at play, right? I see 4 transformations. If we start with the innermost transformation is going to be that -1. That tells us we need to move to the right by 1, right? So we move right by 1. Let's see, did any of these move to the right by 1? If we trace that peak, A may have moved to the right. It looks like they all moved to the right, okay? So then the next transformation, we multiplied the outside by 1/2. So we multiplied the outside by a number between 0 and 1. So then that's going to cause a vertical shrink, right? It's going to cause a vertical shrink. So it should be smushed. So it should not be D because D doesn't look like it was smushed. And then it was flipped upside down. So what's the difference there? Okay. We said it's not D, right? We went right by 1. Okay, we compressed by 1/2. We flipped it upside down. So the ones that are upside down are B and C. Trying to see the difference. Oh, okay. And then lastly, we have that +3 on the outside. It tells us to move up by 3. So if we're going right 1 and up by 3, it looked like it's a B. Let's go with B. Okay, let's check. Okay. Let's do one more. Hey Google, give me a random number between 1 and 20.
Here's a random number. 11.
Okay, 11, 12, 13. We'll go ahead and do 14. This will be it. 14. Write an equation for a function whose graph fits the description given below. Okay. Let me go like this. All right, so it says we're starting with x cubed, right? So what I'm going to do is do a parentheses x to the power of 3. I'm starting there. It's the next part says it shifted 5 units to the left. So that means we need to add 5 on the inside. So plus 5, okay. Stretched vertically by a factor of 2. So if it's a vertical, that means we need to multiply the outside by 2. Flipped horizontally over the y. So I'm going to replace x with negative x, just like that. And then shifted 3 units up. So we're going to say plus 3. I think that's it. Okay, gentlemen, are there any burning questions before we go our separate ways? Okay, so we kind of talked about the greatest integer. It's no real major announcements. Again, just stay on top of your attendance. You get your attendance by basically getting into these Zoom calls. Once you got your attendance credit, you're good. I mean, once you get into the Zoom, you're good. So just be sure that you're getting your attendance, and then, you know, submitting your assignments on Pearson. And also I think this group has a lab, right? So be sure that you're working on the lab with Dr. Lamar. And just following her instructions when it comes to the lab. Okay, gentlemen, if there aren't any other burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy your weekend. See you next week, same time, same place, guys. Take care. Peace. Hey, Siri, play some no copyright music. Hey, you can see me dance. See, like, and then as soon as I'm not thinking about this, I wake up. Like, it's so wild. It's so wild. My body's like, man, I don't want to do this. Maybe I should have this playing through the whole time. Give myself some energy. All right. All right, gentlemen. Have a good weekend.